this might be quite nice to try out on a piece of typography. So I'm in Affinity Designer here. I have two curves. One is the sweet and the other is the T. So as you can see, it's just a simple curve. Let's export this from Affinity as a PDF. To get us up to speed, we're going to be using some free plugins. The first of which is OD import vector file. Let's find our PDF. Don't want that, don't want that, don't want that, because we're just dealing with a curve. Okay, so that's an import, but as you can see, it just comes in as a flat poly. That's fine, so let's deal with this. So extrude, select our front polys and delete. Point mode, select all the back points and delete. So we have a 2-point poly chain. Let's do the same. Just a bit of overhang there. I want a bit of offset between each letter, but I'm not going to go to town on this demo. So let's keep it quick and dirty. Select our first point in our 2-point poly chain. Our next free plugin will be, here it is here, weight outwards. So keep that default, maximum step, yes, so it goes from 0 and it will work its way all the way around here to 1. Okay, that, you see it's doing its stuff. Very nice. Okay, so weight map, select this weight, T for move. We want to select the weight map for the fall off. And we're just going to move it out for this. Like I say, it's only a demo. That'll do for this. And also let's take the T cross and move that forward so it, remembering of course to reset the tool. Let's move that forward so it crosses at the relevant point. The only thing left to do now is to convert them into splines and split them into layers. Final free plugin, EF toggle line curves. We'll convert that 2-point poly chain into a spline, and the same with the T. Square bracket to connect everything joined to it. Turn that into a spline. Cut that into a separate layer. That's it for our modeling. Save that, send it to layout. I've renamed the layers in our spline object type and cross, but obviously we can't see those at the moment because they're splines. So let's make them active. Create a new null. Let's call the first one sweet. Let's give it a color because we can. Helps visualize what's going on screen a little better. Spline control. Let's go to type. Make sure your spline control is turned on. We only need a curve to see this. There we go. Let's do the same for the T cross. Let's make that green. Spline control, and let's point that to the cross. The first thing you can see is my spline for the cross is starting at the wrong place. I want it to start from this side. So let's just quickly jump back to modeler, select our spline for that, and sure enough this little dot is at the wrong end for me. Flip it. Okay, so without having to touch anything, it's automatically updated, which is good. We're going to add particles to these two nulls, so we need to animate it along their Z position as we're using splines. Let's lock the two splines so we don't actually select those. Now I only need modified channels here. Frame 120. Use this little slider here. Now unfortunately we've got to eyeball the very end position as there's no option to select as a sort of a covered distance as 0 to 100%. However, if somebody from New Tech is watching, we have our path, but it's quite uniform as it's just a straight A to B sort of speed. Let's give it a bit of dynamic. Starting at the beginning, we may want to slow it down as it reaches the high points. Get the graph editor up. I like to use filter static envelopes, so only the keys with keyframes on pop up, which means I have a nice clean graph editor in this case. So I'm at the point that I want it to slow down. Add a key at that point. Perhaps a good speed up there. Slow down around there. These are the points on the spline where I want them to slow down slightly. So with those selected, I'm just going to add the endpoint as well. TCB spline. Press F1 on the keyboard and drag left and right, and that should just slow them down at those points. Let's do the same with the cross spline. So just as that finishes, let's give ourselves a few more frames. just as that finishes. Let's move our first frame there, and perhaps 160, a little quicker. The end is kinda in sight, so it's time to add some particles. We will start with our sweet null. Let's go to the end, P for properties, jump over to the effects tab, add effects, and we want an emitter. Everything looks a bit bonkers. Let's tame our emitter. Go to frame, let's generate by frame. Nozzle, we want spheres okay, but we only want it tiny. There we go, so it's all at 0. Whee! There they all go, looking a bit strange. While we're here, let's knock the frame rate down to 10, so there's not quite so many on screen at the moment. Particle, under particle lifetime, we will just put at 0 for now, so it lasts forever. Under the etc tab, parent motion, knock that down to 0. So as you can see straight away, we've got a nice trail of particles. But as you can also see, it runs out around about this point. Now 120 frames is the length that this null takes to get from 0 to the end of the path. So 10 times 120 will give us the maximum amount of particles we need for this point. Let's turn off the spline. Now I really want these particles to be quite closely compacted together, and that looks pretty good, but if you wanted more, say 20, see that's also as nice. In fact, let's keep it at 20, but we'll also need to edit the amount of particles, so again 20 times 120, and that should take us to the end of our path. Same for our cross, particle emitter, frame, let's just go for 20 as well. The generator, the base there, leave the particle limit for the moment. Particle lifetime 0, etc. Parent motion is also at 0, so that don't move. Nothing's happened. Let's go back to our generator. Fixed. Start frame. 122. Okay, that's nice. But after that point, we want them to stop generating on frame 153. So our particle limit will be 153 minus 122, 31. 31 times our 20 will give us the exact amount of particles we need. I'm going to be using Lightwave 19's Open VDB to stylize these particles. Prior to that, there's no reason why you can't use hypervoxels. In fact, arguably, you've probably got more control over relative particle age and particle age, which you don't, as far as I can tell, have with Open VDB. If anyone can tell me different, that would be great. But for this case, it's just a single stream that we're styling, so it's not as important. To add sweet emitter, particle size. Now, as mentioned, Open VDB will need the output size. So we need to, firstly, let's see what we're doing. Show size, too big. Output size. So this is the setting that Open VDB will be getting. So where's this particle size? Show particle size. This is what we're outputting. So let's start with a little number, 0.1. A little bit too big, 0.01. A little bit too small. In fact, what I'm going to do, I don't need 20 for now. Let's go for 10 particles, 10 times 120. Now the way we're going to do this is similar to the way we slowed down the spline. We're going to use an envelope on the particle size. So when we get to a point, let's say here for instance, where we want it to be a little fatter, let's add a key and make it a little fatter. Let's bring that in a bit. If one drag just to smooth that out. doesn't have to be too extreme, especially not with this typography stuff. It depends a lot on your design, obviously. That's okay for now, and then go ahead and do exactly the same thing, but on your T-cross. A little issue I've come across with the particles, as if you can see as we're playing through the timeline, they all sort of jump around a little bit. Now we definitely don't want this for the open VDB stuff, so the cure for that is, because it will be the same on both nulls, select both of them, motion options, and what we're going to do is we're going to remove the spline control on the rotations. So what we have now is a nice solid particle path. Let's make full use of the particles. So we've built them up, now let's kill them off. Let's extend the timeline a little bit. Now each of these particles have a lifespan. So what we can do is it kind of all finishes around frame 147, so we could give it a lifetime of, let's say, 150. So that will animate on, so at that point they should all animate off. In fact, giving it plus and minus. Okay, that's good. That's a good first step. Let's also add a little bit of dispersion here as well. So we've got the spline, we know what that is, we know what the path is. Let's create a new null. So there's our dispersion null. And for motion options, let's select our type spline, that one there. Sweet spline, go to modify copy path, or rather copy motion, dispersion. Let's colorize that. Dispersion, paste motion. So now we should have two nulls on top of each other. So F2 to get the graph up. We don't necessarily want it to slow down at those points. Set the path, so frame 150, perhaps a little earlier. P on the properties, effects, we want a wind effect. Let's go for a random wind. Let's lower the radius, raise the power. That's good, but you see it's obliterating the T cross at that point. So let's isolate those. Let's create a new group. Okay, so that's in the type group, and then we'll go to our sweet spline emitter, and we'll put that into our type group, so they all belong in the same groups. So now we have a nicely dispersed piece of type. Don't need to show the size. Always keep it output size, but you don't need to show the size. Let's do a similar thing with the lifetime. So that's all disappearing. Let's have it disappear around 218. Ha! Remembering our time offset here. Actually, I'm just going to guess. So the wind is affecting the particles right at the beginning. There's an easy fix for that. So under the dispersion, P, go to the wind, power, let's just animate the power. Stick an envelope there. We want it to kick in at that point there. Add a key there. Value of 0 at the beginning, and make that a stepped key. So that should now have no effect until it starts moving. Let's start with the open VDB stuff. Now I'm just finding my feet in this, but I know just enough to get the ball rolling. New null. Let's call it VDB. VDB. Okay, that P for properties. Primitive object replacement. We want the open VDB evaluator. Moving to a frame where we can see our particles. Now we're dealing with particles here. From particles. Particle system, we'll start with the suite, which is our main type. That's our particle system. Particles move slightly at the end, so we'll put on trail. Voxel size we'll leave there. Space, let's put that into world space. Because we're using two particle systems, the voxel sizes need to be the same, so we use a scalar for that. And we'll just repeat that number that's already in there, just to double check. 0.05. So the grid into the grid. This is where we hold our breath. We may have to nudge the arrow keys left and right just to update the frame, but as you can see, not a lot has happened. The way I see this voxel size, it's kind of like a resolution setting. So if we don't see anything, it's because this value is set too high. 0.2, missing this section here, 0.1. Perhaps we go slightly, let's go to 0.8. If we have a look at the wireframe, we can see it's quite dense. Now what I found is by adjusting this value here in the Open VDB node, the adaptive, if we knock that up, greatly reduces our polygon count, which will be a lot easier to work with. And if you're a fan of the low poly look, then this is definitely worth further research. I'm going to keep it there for now, just so we have a workable amount of polys. Let's add T cross to this. Copy and paste this one, I think would be quickest. Particle system cross, exactly the same settings. Use that same scalar value in the voxel size. Let's just plug that in there, just see we're getting stuff. So that's looking okay. We need to join these two systems. We do that using the CSG function. So plug both grids into each grid, the output grid of the CSG into this grid, and this defaults to union, so that's exactly what we want, and that's nice. We've got a nice merger at that point. I want to move this cross forward slightly. Let's select the cross, and then this is where I like to use the fixed keyframe function. Let's just nudge forward the spline, but as you can see, not a lot is happening. We need to tell the particles to update. Even if I turn off the evaluation, you can see I've got a slight offset. Let's turn the evaluation back on. Now we can't go via the properties with Open VDB being evaluated, but we can go via the effects browser. So if you're in Lightwave 2019, the Control Shift option, effects _ browser is the route to go. We want to go to our cross, nicely bring up the properties. Now I found clicking the world coordinates does this quite nicely. Back on the cross, let's nudge it back. So yeah, try the world coordinates, it seems to be doing what I want it to do. Back to OpenVDB, it's time to smooth out our geometry. This is where I will need to put our adaptive back to 0 and get a full idea of what's going on. The first approach to try is a filter. So this will, in this case, if I select dilate, will enlarge our geometry from the normals, I think. Voxel offset 3. Let's add another filter. Let's select Gaussian, which will smooth stuff. Actually, let's not forget to add smoothing as well. Now the voxel offset doesn't have a great deal of effect under Gaussian mode, I found, but the iterations do. And let's go back to our effects browser. Let's select our suite particles. We can go in and edit our shape still. It may be quite laggy. Perhaps this is where we knock the adaptive back up, just so it's slightly more workable. So we've made a few tweaks to the path. Let's put the adaptive back to 0. We could try and dilate it a little bit more. We smooth it out, and then we could also, another filter, we could also try and erode it, so shrink it back down again. Yeah, you really need to experiment, because as you see we've lost the holes there, so perhaps that's one step too far. So let's scrub the timeline, there's quite a nice effect. The good thing about particles is you could add all sorts of wind emitters to affect the path. OpenVDB has its own particle system as well, so you could texture it further. Lots of potential. Final step, let's just save what we've done, or rather bake it to a file. So we go to the saver, output of the final grid into the saver, into that grid. Sequence, we will save the path, goes into a grid cache automatically created for me, so okay that. Click on the save button and let it work its magic. In this case up to frame 300, so make sure your timeline is long enough. So after a cup of tea and a good night's sleep, that's finally baked. Go to the open VDB info. That's there because I tried it earlier. Anyway, so go to the grid cache file, open up the first channel, filter grid, sequence options, that should give you the full timeline animation. Just click that into the grid and we should be good to go. So now it's baked, it could be a good time to add a whole level of other secondary animation on top. So a whole array of deformers open to you. So go and have fun.